whoa, mammoth lesson here. Okay, section 12, lesson 4. This is the 6th. It's going to be short. So I know there was part 4 was 15 minutes. I know that was a beast. Part 5, some ideas reinforced, and we added something new. We're going to add something new to I. Square root of -1. So let's zip ahead. Let's say you want to factor this completely. So if you find the rational root theorem and then look at the graph, so I definitely get something really different. So I find these possibilities by the rational root theorem. I look at the graph and I say, holy cow, yeah, it's a cubic. So it might cross the graph 3 times, but it totally does not. It's got a little wobble instead. So I've got this wobble. This is this below the x-axis. So if you see a wobble above or below, and sometimes it's barely a wobble, that means you might have some complex roots. You might have some i's in the roots. So let's look at what the real root is so we can count over, get an estimate, and do synthetic division. If you're saying, ooh, I don't see the wobble in my graph, then you might need to reset your windows. I've put my windows up here. Keep x between -10 and +10, but let your y go between -50 for the y min and +50 for the y max. If we were to proceed like we would if there was nothing funky or funny going on, we would have said, okay, we're going to solve this. We use the quadratic formula. We end up getting a negative in the square root. And maybe some of you have seen this before, maybe you haven't. So when we do that, we think about, geez, what if that negative wasn't there? Well, then I'd really look at square root of 20 times the square root of -1, because we're going to define square root of -1. You can see it's coming. It's down here. Square root of -1 is I, and maybe you've seen that. So I'm going to say 2 root 5 times the square root of 1. I've continued to simplify and leave that square root of -1. We're going to just call it I. So I can proceed in exactly the same way as I did before, x minus the 0, and that's not quite simplified, and it got a little bit squished up at the end there. So I still have x minus the x-intercept, x minus, and now you can see why we call it a 0 or a root and not an x-intercept, because it doesn't really intercept the x-axis. So I've got x minus each of those guys, and I've put them in blue so you can see them easily. So let's explore, what is this square root of -1? It's I. It's an imaginary number. And if we combine an imaginary number with a rational number, we have something called a complex number. So these are imaginary numbers. And they actually were studied in secret in the closet because mathematicians were ridiculed for studying it, but there ends up being an amazing application. If you ever take electrical engineering, then I think you'll see the amazing uses of I. So the way I is defined is as the square root of -1, I squared, equals -1. So that's part of the definition too. So the hint, and what I want you to do is just treat I just like x, except if you ever see I squared, it equals 1. Hang on, it equals -1. I lost a negative. That's really critical. So let's actually, do you see that right there? Wow. Okay. So let's go down. Let me actually clarify equals, and this makes me really nervous, -1. So I've got it right in one place, and then the other, I think I dropped my negative. So let's actually treat it just like an x and see if you can figure out what to do with these guys. So here's the first two. So you see you can combine these two just like you would if I was an x, and you can obviously combine the 2 and the 5. So we're there and we're done. We can FOIL this out, first, outer, inner, last, and I want to combine like terms. So you can see I've done that here. And now I think, well, I squared equals -1. So instead of that I squared, I'm going to sub in a -1. And -1 times -12 is +12. And so therefore I can simplify that way. I'm a little squishy on the space here, so I'm going to zip down here and then go back up to this one. There's that. Let me know if I made a mistake. And now, because I ran out of space, I did it on my blank paper over here. Again, let me know if I made a mistake. I try not to, but. And now let's actually take a second and see. This looks like maybe you recognize it as a difference of squares, but that all-important difference of squares rears its beautiful head right now. So FOIL this out and see what happens here, and that could be a useful thing down the road. Isn't that cool how it happened? That middle term disappeared in the same way difference of squares, middle term disappears. So so this is a nice thing if you don't want to be working with I. Maybe it's, say, in the denominator or something. Now, what else? Is there something else we want to notice here? I think we're good. Now, here are 3 more examples. I'm going to show you all my work to all 3 of these examples so you can do, and I'll show them one at a time. So this is a great place to practice where I will show absolutely every step I possibly can. So let's start with the first one. Okay, I could show you the graph of this too. You can see there's the graph. It looks a little dark. Let's see if I can lighten it up a little bit. So you can see there's a wobble below. I didn't change the windows from the last time we did this, but you can see what the factorization is. Let's look at the next one together. How's that? You might not even need to list all these guys out, but you do want to verify that the value that looks like it's crossing is actually one on the potential list. So here we go. We factored. That was nice. We did the quadratic formula. Notice that if you were now to FOIL this out completely, you should get what you started with. You should get the original polynomial up here. One left for practice. Here it is. Rational root theorem. Looks like it's 2. You actually get a really nice wobble there. Let's see if we can brighten that up. Really nice wobble below the axis. That's what complex roots generally look like. And wow, I did the quadratic formula. I got the possibilities for x. If this expression here equals 0, I get these values. So I can write out the complete factorization here over the, we said over the complex, or with respect to the complex numbers. And for those of you who want a little bit more, I could have a problem like give you the roots and you find the function. Here's an example. Find a possible function if those are the roots or the x-intercepts. And so then you can set the factors, FOIL that out. Now, what's really interesting, this is one possibility. There's an infinite number of possibilities. If you stretch if you stretch by 3, or even if you stretch and flip, the x-intercepts stay the same. Flip on the x-axis, that is. The x-intercepts stay the same. So, because all that is a vertical stretch. So I could take 3 times that function and get this, and the y-intercept is now -6, but the x-intercepts stay the same. I don't know what happened to me there, but I disappeared. But you can see that vertical stretch. X-intercept stay the same. So the y-intercept is now -6 because I did stretch it. So from -2 to -6. So then the next question is, so find a possible function. Where is it? Find a possible function if the roots are -3 and 2/3 and the y-intercept is -12. Use the last one and the last idea to find this. Just take the previous function and multiply by 2, and lo and behold, there's your y-intercept of -12. And all of these functions shown that have been stretched from the original all have the same x-intercept, different y-intercepts, but the same x-intercepts. Homework worksheet.